So in this slide, you can see again some pictures taken during microduct installation in Azizia area. Okay, so starting from the left upper portion, you will notice that the spacers were not properly installed. Also, there's no proper sun bedding, and you can also see that the microducts were not properly secured and no cover at all. Okay, so it will allow dirt to enter easily if this is the case. Below pictures on the left, as you can see, is that the main seven-way ducts were not properly sealed, or there's no proper caps. Okay, and there's no even correct clearances to the manhole wall. Then you also have the microducts, which were not properly cut with the proper cutting tools. Okay, and finally, on the right side portion of the slide is the seven-way main ducts were deformed, perhaps caused by mishandling the duct and duct itself. Okay. So another sample of pictures of improper installation in the field. As you notice, manhole is not aligned to the trench. Duct spacers were not also properly installed, as you can see in the picture. As you know, guys, as per STC standard, duct spacers must be installed 1.5 meter apart. Plywood were used also to cover the knockout windows instead of grout. Okay, so the trench is also beyond STC specs, causing the contractor to spend more time in concrete backfilling. There's no sand bedding also, which will pose danger to the ducts and might get punctured later on. Okay, so let's move on to backpull or stationary reel method. So when do we need to use this method, guys? Okay, so use them on routes where space is limited for heavy equipment. So that is one. It can be also used in road crossings, trench with obstacles, and we can also use this method in a long distance route where the soil is not excessively rocky. Okay, so figure 30 is just to show you a stationary reel and where it has to be used. Okay, in some cases, ducts can be also pulled by a pickup truck. It can be tractor, it can be backhoe or similar, with taking great care during pulling. Avoid excessive tension and force all the time during pulling. Okay? Polyethylene corrugated duct can be pulled directly to a 40 centi wide trench as shown in figure 31. However, if trench is 20 centi wide, okay, the duct should be deployed alongside the trench and lower the trench manually as shown in figure 32. Okay, guys. So drive off or moving reel method. What do you know about this method, guys? Okay, so drive off method is used on routes that can be traversed by reel carrying vehicles. It could also be used outside the cities, an area with abrasive soil or rocky pavement. As much as possible, the vehicle should be positioned near the open trench to allow easy laying of duct directly to the trench. As you can see in figure 33, this shows you how a moving reel must be positioned along the trench. Okay, so let's talk about mold plowing method. Who among you guys have tried this or have experienced this mold plowing method? Okay, so as you know, this method is very common in long distance network. Okay, this method could only be applied if the pavement is sandy or soft. Otherwise, if it is not, then use another trenching method. Okay, prior to mold plowing, you guys need to perform proper and correct precautionary measures like ground scanning, test pit if necessary, and coordination with other utilities, municipality, and other agencies involved. By doing this, it might save you from any, damages to existing utilities underground during execution. Okay, so this plowing method can also install multiple ducts, okay, including warning tapes and earthing as required, and closing simultaneously the plowing furrow. Okay, is it clear? So this is the plowing machine on the right side with its itemized parts like the drum mounting, drum brake, guide roller, lifting mechanism, and many more. Okay, so the plowing method can be divided into the following working steps. Number one, concerning external lines and soil quality, selection of plowing units and drilling tools, removing of bushes, fences, and hindrances. So you have also reconnaissance of the plow path course, laying out of ducts or installation direct from trans transport vehicle. So we also have plowing, reconstruct the surfaces, and preparing a scale accurate drawing of the plowing course. Okay, so the remote plow has its features to produce vibration on the plow share in vertical direction. Okay, so this loosens the soil and cuts a clean narrow duct laying trench through it. Due to the vibration during digging, fine sand falls to the bottom of the trench and all large debris moving onto the surface such that the duct is always protected by sand. Okay, so in this case, backfilling is no longer necessary in this method. All right. Okay, so we move on to the installation of multi-way up to 8-way 110 mm ducts. Okay, we also have installation of over 8 ways 110 mm ducts, and we will also discuss here about the installation between mini manhole and handhole, okay, including road crossing. Okay, so installation of multi-way up to 8-way 110 mm ducts and installation of over 8 ways 110 mm ducts both don't require concrete encasement. However, as an alternative to using duct space, 12 mm steel bars are used, driven into the ground at 1.5 to 2.0 meter intervals along the trench to keep the ducts in correct formation. On completion of the duct nest, 6 mm steel bars should be placed horizontally across the uppermost layer of ducts and tied 75-meter interval to the vertical bars. Okay, so duct installation between mini manholes, including crossings. So shown below is a typical trench route in the secondary network. So the stationary method is the preferred method because of the existence of existing utility ducts along the trench, including road crossing. So as you can see in the picture in figure 38. Okay. This slide will just guide you how to install ducts step by step when crossing streets or road crossing. Okay, so step one. Let's say that you want to excavate from point A to E. But before you can complete the trench, there are procedures that you need to do so. So these are the procedures. Okay. So excavate from point A to point B, shown on the right picture, and also B to C and D to E. Leave point C to D open for traffic as shown in figure 36. Okay. Use steel plates to provide temporary cover on all private driveways to avoid any inconvenience for the customer. Okay, so that's step one. Step two, position the reel near point C, then pull the polyethylene corrugated duct from point C to A as shown in figure 39. Step 3, cover the trench from point A to C and leave point B to C open for traffic. Then move the reel to point D as shown in figure 40. Okay, so step 4, excavate from point C to D, then unreel the remaining length of the polyethylene corrugated duct and cut it to the required length and lay it onto the ground. In case there is no existing ducts in the trench, the remaining polyethylene corrugated duct is kept on the reel. Then ensure to place the loose end of the duct below the reel. Then roll the reel manually along the trench and spooling off the duct while rolling. Timing is very crucial as such that the duct shall be ready for installation right away after the trench work from point C to D is completed. Okay, so refer to figure 41. Step 5. After excavation from point C to D, pull the remaining length of the duct into the trench or roll the reel and place the duct in the trench directly if there is no existing pipe as shown in figure 42. And finally, step 6, complete the backfilling and reinstatement of the trench, then clear all the construction materials and debris on site. Okay. Okay, so sealing of ducts. All empty ducts shall be sealed at all times. Either it is completely installed or not yet installed. So this will prevent ducts from water entry, dirt, or foreign objects. Microducts shall be sealed as well with the prescribed end caps approved by STC. Main ducts installed in mini manhole, handhole, or even in a cable vault or cable chamber should be sealed with foam. So, if there is new installation, contractors should not be charging for extra services for the sealing of ducts or even installation of end cap because these are already included in the new installation. Next topic is duct configuration and formation. Duct configuration and formation. This slide will tell us about the standard configuration of ducts in the feeder and distribution network. Between central offices or exchanges towards the access sites, a 20-way by 32 mm duct with a configuration of 5 by 4 is being used, where 5 ducts are orange, another orange black stripe, and 10 black pipes as shown in figure 43. 20-way by 32 mm and 12 bundles of 20 mm could be also be fitted in one knockout window of a manhole or handhole, as shown in figure 44. With regards to the drop ducts, a 2 by 2016 is used to the customer end from the nearest manhole handhole. All right. In a long distance network outside cities, towns, and villages, A 110 mm corrugated PE duct with a pre-installed 5 by 32 mm subduct has to be used, as shown in figure 46. Take note that do not receive any material from STC or vendor of this kind if there is no installed copper wire in the duct sheath, because this copper wire will serve as a detector to pinpoint the position of the duct underground later on. Until this time, microducts in the long-distance network is not yet being implemented until further notice. Okay. However, in the feeder and distribution network, microducts are used, and most of the application is on the NBB projects. So 7 by 25 mm HDPE microducts of 3 bundles is used in both feeder and distribution. In table 7, you will find the duct color codes for the 7-way microducts, where inner duct or where yellow is the duct number 1. Okay, blue is duct number 2, green is duct number 3, red duct 4, gray duct 5, white is duct 6, and orange is duct number 7. Okay, so below this slide, in figure 47, you may also find the duct formation, where yellow is bundle number 1, blue is bundle number 2, and green is bundle number 3. Okay, so microdrops for lead-in. For microdrop without sharing, that configuration would be 1 by 2 of 12/8 HDPE pipe to be installed in villas, buildings, or any other infrastructure from the nearest handhole or manhole. Color codes in this configuration would be yellow-blue, okay, where yellow is the duct number 1 and blue is duct number 2. The only difference of drop ducts with sharing to drop ducts without sharing is the duct configuration, where duct formation would be a 2 by 2 configuration, okay, where yellow is duct number 1, blue is duct number 2, green is duct number 3, and red is duct number 4, as shown in table 9 of this slide. Okay, so in this slide, we're gonna discuss the main ducts configuration for copper, lead-in drop duct configuration for copper, microduct configuration for long-distance network, and duct bend requirements. For main duct configuration for copper, basically guys, this configuration is used between Emson and copper cabinet, where a combination of 75 mm HDPE pipe and a 3 bundles of 7-way by 25 mm microducts are to be used in a common trench. For lead-in in the drop or for lead-in in drop in copper, which is basically used from distribution point to the customer, a combination of 50 mm HDPE and a 2-way by 12/8 mm microducts are to be used. Okay, so for the microduct in a long distance network outside cities, a 4-way by 25 mm HDPE pipe with a metallic wire is to be used. With regards to the duct bends of these ducts, okay, we have here a different situations in table 11, which will guide you regarding the bending requirements. Let's say you have here situation number 1, common trends T intersections. So requirement, no bending requirement. What if you have a trench direction changes greater than 90 degrees? So no bend requirement still. However, if you have a trench direction changes which is less than 90 degrees, okay, So we need to consider the bend, okay, in the duct section. Road crossing primary cable run is continuous, and road crossing T-off non-continuous, so no change. So let's talk about the bending in a section. If you have a less than 90 degrees or equal to 90 degrees bends, okay? So if you have one bend in one section, okay, you need to make sure that the length of that section must not be more than 270 meters, okay? So typical distance between manhole or handhole to handhole is from 240 to 270 meters, okay? But if you have two bends in one section, okay, let's say manhole to manhole or manhole to handhole, okay, you make sure to obey 140 meters to 170 meters maximum length of that particular section. Okay, guys? DUCT or cable location markers. Okay, it is very important that when you are implementing underground network in a long distance route, location markers must be in place or available to determine the exact position of the ducts or cables underground. As per STC requirement, location marker must be installed in manholes, handholds in a long distance route, or rural areas. If it is a direct buried cable, marker post must be installed every 400 meter. Okay. However, if cable is ducted, then you guys need to install marker post every 250 meters apart. Also, if there is change in cable route or direction, like crossing, river crossing, wadi, and culvert, a marker post with two black stripes is also required. If there is a splice closure, two marker posts with three red stripes shall be installed in both ends of the handhold, as shown in figure 53. So let's move on to the crossing requirements. In a long distance network, you guys oftenly encounter these situations: crossing river, culverts, bridges, tunnels, or even railroad crossing. For example, in wadi crossing, take note that during survey, the surveyor must identify clearly if the wadi is dry or just a culvert, or if the wadi is with water, wet, or if it even requires special protection. This is very important during survey because plant units that you are going to apply in these scenarios are totally different. And for dry wadi crossing, meaning that only a small amount of water flows during rainy season, plant units that you should apply, okay, or use will be 1200.025, which is for a supply of 1 by 110 PEC duct, okay, with 5 by 32 mm subduct on it, with a concrete encasement. Another PU is 1030.001, which is for extra excavation in soil. And finally, 1035.001, which is for the breaking and removal of rock if it is only required. If the wadi has a strong current of water during rainy season, plant unit applicable to this situation is 2500.001, where you need to have at least 1.8 meter cover over the ducts if it is rocky, and 2.5 meter cover if it is in a normal soil. The difference of these piers is that an additional erosion dam is installed to protect the duct banks from exposure during rainy season. Okay, because normally during rainy season there is a strong current or flow of water in the riverbed. In figure 55, the trench profile of junction and long distance network, if it is a standard ducts passing rivers, wadi or culvert, would be 400 mm by 1.8 to 2.5 meter depth, depending on the type of soil. Okay, with 2 by 1 of 110 PEC, with a 5 by 32 mm subduct on it. Okay, encased also in concrete of 400 by 420 mm. Then from the ground level, warning tape is located 600 mm below the ground. In figure 56, where you need to cross wadi, culverts, and rivers, if you have feeder or distribution, trench profile for 3 by 7 way of 25 mm microducts would be 400 mm by 1.8 to 2.5 meter depth with 225 mm by 315 mm of concrete encasement. Then you need to have a warning tape installed 600 mm below the ground. And for long distance network using a microduct, 2 by 2 of 25 mm microducts is installed in a 400 mm by 1.8 to 2.5 meter depth of trench encased in a 50 by 50 concrete. Also, warning tape is the same. It is installed 600 mm below the ground. Okay, so let's talk about special protection for erosion dam. As I said, the purpose of this erosion dam, which is installed in wet wadis or culverts, is to protect the installed duct to get exposed during rainy season. Erosion dam's job is to break the flow of incoming water such that it will not directly hit the encased duct. Okay? So an illustration of erosion dam is shown in figure 57 for your information. Okay? So this erosion dam is constructed of concrete slabs recessed in the sides and at the bottom of the trench to a minimum depth of 200 mm. Okay, so let's move on to bridge crossing. When crossing a bridge, make sure that before you install a new pipe, ensure that there should be no more available ducts to use. Okay, so always use existing ducts as much as possible. Okay, if it is already saturated, then it's a time to install a new one. You guys need to coordinate with proper authorities and acquire the access permit before execution. With all the proper requirements prior to implementation, a 110 mm HDPE, PEC, or free ducts shall be used. Where it is required, ducts shall be encased in concrete where they traverse the bridge supports and enter the ground. The most common method of installation in this case is by the use of hydraulically operated crane fitted with safety basket. Okay, so when you guys implement this bridge crossing using ducts, safety precautions shall be observed always during execution. Okay, figure 58 in this slide is just a sample of a bridge crossing where HDPE, steel pipes, or similar are attached to the side of the bridge, either using a steel bracket or directly attached to the wall of the bridge, depending on the approved method by the concerned agency. Okay, so let's move on to the tunnel crossings. What are the important considerations? Always secure first permit, okay, from respective authorities prior to installation. When crossing a tunnel, always observe that ducts should be installed 3 meters minimum height above the ground. Where there is less than or equal to 600-volt electric lines, a 300 mm separation shall be observed. Okay, so if the electric power is more than 600 volts, then you need to install the ducts in the opposite side of the tunnel. Okay, so what about railway crossings? Again, always secure approval from the proper authorities because there are certain requirements and easement within railway boundaries or corridors. With all requirements being satisfied, make sure that the design and duct installation when crossing, okay, conforms with the railway load. The telecom duct should be installed 1.8 to 2.5 meter in depth, okay, under any railway line. Thrust boring method is the most recommended technique in this kind of scenario.
Now the topic will be discussed, which is tests on microducts. Air blowing test. This test normally performed on individual microducts to detect air leakage in that microducts. Normally, the one end of the microduct connect to the air feed compressor through the duct calibrating equipment, while the other end to be sealed or closed using an end plug. Now compressed air will be fed into the microduct with pressure to be raised 5.5 kg per centimeter square and the inlet valve to be closed. Just wait for 10 minutes. If the pressure does not drop 5 kg per centimeter square, in that time pressure test is passed, which means the pressure drop of 0.5 bar is permissible. On the other side, if during that 10 minutes pressure drops below 5 kg per centimeter square, the pressure test has failed, which means during that time pressure drops more than 0.5 bars, which indicates probably the failing of test is a coupler leakage or a puncture in the microduct. In addition to that, the microduct should be cleaned from any water or mud inside the tube to check its integrity by following the steps below. Step 1. Prepare a sponge about 4 cm long or double the size of a tube diameter. Step number 2. Insert sponge into the tube. Lubricant has to add. Step 3. Supply compressed air into the tube. So in the pictures below you can see different step-by-step procedure. So step 4 is check outgoing sponge and repeat if not clean. So in simple words, we just insert a sponge inside the duct, insert some air as well, and the sponge has to be come on the other side. Mandrel test or ball pass test. There are a number of steps to be followed for this test. Step number 1. Prepare a ball of steel or plastic which has to be 85% of the inner tube diameter. Step 2. Insert ball in tube and then supply compressed air in that particular tube as well. Step 3. A metal mandrel is recommended for main ducts, whereas the wooden mandrel is also acceptable for subducts to be regularly checked. Step 4. For main ducts and subducts, mandrels with a diameter of approximately 90% of the inner diameter of the duct shall be used. Number 5. All mandrel tests shall carry out in presence of STC inspector and also shall be properly documented. Availability of the following resources should ensure before proceeding for DIT or duct integrity test of new stretch where two ducts to be used or tested. Step 6. When undertaking duct integrity test for the duct, it's recommended for the contractor to use ball, shuttle or mandrel depending on the size of the duct. Duct integrity test. The contractor must submit DIT test report upon completing the DIT test. The tools and equipments to be used are 3 walkie-talkies along with 3 chargers, 3 PTE along with fittings including hoses, 4 transmitters and 4 housings, 1 receiver, 8 shuttles, 4 end couplers, 1 vehicle on rent at site, 28 end plugs, 14 push fit couplers, 2 brushes, arrangement for getting 2 outlets for compressor for 2 PTE and 1 release valve, 1 compressor along with tractor on rent at site, 2 catches, flexible wire grip and a sponge 1 by 1 meter dimension. There is also some special requirement: 1 funnel, 20-liter can for storing water, 1 bucket. There is also tool bag which consists of 3 rotary cutters, simple cutter, C-spanner, drafting knife, torch, plastic hammer, slide wrench, small notepad and pen, sketch pen of 2 colors. There is also some consumable items which are 28 transmitter batteries, 3-volt lithium battery actually, 16 receiver batteries, 1.5 volt LR6 batteries and 2 paint boxes yellow, 1 length of 2 pieces, plastic hammer, line and patch diagram format, DIT format, There are also some duct pieces which must be at site: 6 green 5-meter length and 6 orange 5-meter length. 3 green 1-meter length, 3 orange 1-meter length. Also rope for tying duct pieces at site, a line 5 kg for marking of pits to be dug at site. Finally, the manpower required for this process is technicians, total of 3 technicians, contractor engineer, supervisor must be available at site, and finally 6 laborers with digging tools must be at site. Now the topic to be discussed is backfilling. Backfilling. Consolidation compaction is mandatory in order to maintain the density of the soil and ensure the smoothness of the surface reinstatement. Now we have some general requirements. Number 1. The contractor shall carry out backfilling of trenches and other associated excavation immediately after the ducts are installed to avoid disturbance to the area by keeping an open trench. If any trench cannot be backfilled at the end of the day, the contractor shall consider security provision to ensure ducts are not vandalized and that the open trench is not a safety hazard. Number 2. Before commencing the backfilling or before starting it, all foreign material, free water, and slurry shall be removed from the trench. Number 3. Backfill material shall not be placed in excavation containing from water or slurry. Excavated material from the trench may be permitted as a backfill above the bedding sand if this material is predominantly a soil. Number 4. Consolidation of the backfilled excavation will be in accordance with the local authorities and infrastructure specification. That means the local authority, either it's a municipality or it's a regulatory authority. Number 5. There are two kinds of backfill that can be used. Selected backfill materials such as fine dune sand, and the other is existing freestone material. Number 6. The embedded zone of a duct trench is that portion of the trench from approximately 100 mm or 10 cm below the bottom of the first row of the ducts to approximately 10 to 15 cm or 100 mm to 150 mm above the top of the final row of ducts. Number 7. External loading capacity of duct largely depends upon the type of embedded material and the quality of installation of the material in the embedded zone. Number 8. The best material to be used in embedment zone are coarse-grained materials such as crushed stone, sand, and pea gravel. Coarse-grained soils mixed with silts or clay can also be satisfactory provided the mix is compatible and stable. Soils not recommended in the embedment zones. Embedment zones are highly organic material and highly plastic clays. Maximum particle size in the embedment zone should be limited to 2.5 centimeter in diameter. Number 9. Final backfill zone of the trench is that portion of the trench extending from top of the embedment zone to the top of the trench. Number 10. Final backfill is not critical for the performance but can be important for providing a proper foundation for a road or other structure that may be constructed over the trench. Number 11. Selection of final backfill material is not critical for raceway. All types of soils are acceptable provided they do not contain particles that can damage the duct. When raceway installations have structures built over them, the final backfill material should be of a select nature similar to the material in the embedment zone. Last point, the project engineer is responsible for the selection of the embedment and final backfill material.
Compaction. Compaction is an important element to perform after the backfill. Now there are a number of checkpoints to be followed. Number 1. Proper compaction of the embedded zone is important for limiting the deflection of the raceway. After compaction, the soil should completely encase with raceway, providing support around the diameter and along the length of the raceway. The soil should be consolidated and free of voids. The density of the soil after compaction is specified by the project engineer and is typically in the range of 85 to 95% Proctor density. Number 2. Compaction of the final backfill material is not critical for raceway performance but is important for providing a stable foundation for structures that may be built over the trench. Number 3. The type of compaction method chosen depends on the type of backfill material used. For coarse-grained, non-cohesive soils such as crushed stone, pea gravel, and sand, vibratory compactors works well. Static compaction devices, which utilize their own weight to compact the soil, can also be used on non-cohesive soils. For cohesive soils such as the finer grain clays, impacting compactors are the most effective devices. Number 4. When mechanical compaction equipment is used, care is to be exercised to prevent damage to the raceway. Handheld, unpowered compaction equipment should be used when there is little soil covering the conduit. Number 5. Water compaction, sometimes called jetting, can be effective for soil that are not expensive and flow when wetted, such as sand. In such soil, water compaction can achieve desired soil densities without risk of damage to the raceway. However, the duct bank should be restrained from flotation if water compaction is used. Number 5. Compaction is best done in layers or lifts of soil of between 15 cm to 30 cm in thickness. A lift of backfill is placed and then compacted before the next lift is placed. Each row of raceway is embedded in a lift before the next row is placed. It may be possible to use greater thickness of lifts when water compacting. Number 7.
Upon the completion of all the construction and backfilling operation, the site should be cleaned up immediately. After the excavation has fully settled, the surface shall be reinstated to the satisfaction of the civil authority. Number 8. Installed trenches in any municipality MOT roads shall be backfilled with appropriate backfill material that complies with the minimum standard as set out approved in the municipality MOT specification. Pour concrete or concrete pouring. There are also number of checkpoints. Number 1, the concrete mix design should have a nominal 2500 psi or pressure per square inch as compressive strength. Number 2, quantity of water must be increased in concrete just at a level so the concrete can easily penetrate by itself from the sides to the bottom of the trench. Number 3, the concrete pour begins at a manhole and works down the duct bank towards the next manhole. The concrete used should assure proper distribution of the concrete. Higher slumps or more fluid concrete may create adverse flotation or buoyancy space between the ducts in each case of concrete encasement. This slide has some photos. On top of these, the upper portion shows photos of the compaction devices. So there are two devices shown which is actually compacting, and down there is also two photos which showing the concrete pouring process. Now we will talk about surface reinstatement. Surface reinstatements for any surface breaking related to trenching or excavation within the OSP civil works, surface has to be reinstated to its original condition. The surface reinstatement covers all type of surface type such as tiles, paved, concrete and asphalt, etc. There are some general requirements for surface reinstatement. Number 1. Any constructed footway must be reinstated with the same surfacing material that existed originally. For example, concrete blocks, slab, etc. Material may be reused if undamaged or else replaced with the similar material. Number 2. After finishing the work, all the equipments, warning sign, barricades, etc. shall be removed from the site immediately. Number 3. All debris shall be removed from the site to an approved designated area. Number 4. The site shall be restored to the condition in which it was found previously as a minimum. Number 5. Reinstatements need to be as per municipality standard specification and avoid reusing excavated material. Number 6. Reinstatement of asphalt may require milling and paving. All milling and paving shall be done as per municipality or MOT requirements. Number 7. Reinstatement in rural area requires leveling and removing all debris from the site. Number 8. Reinstatement work must be done by the contractor. Number 9. The permit holder should do the permanent reinstatement with 2 weeks maintenance period starting from the date of completion in case of temporary reinstatement work. Number 10. Grass area shall be reinstated using the original turf, replacement turf or an equivalent seed. Number 11. Any constructed footway must be reinstated with the same surface material that existed originally. For example, concrete blocks, slab, etc. Material may be reused if undamaged or else replaced with similar material. Number 12. Remedial work will be required if any of the following defects exist: depression resulting in standing water, humps, crowning, edge depression or cracking. Reinstatement of asphalt and paved surface. There are number of checkpoints. Number 1. The asphalt work shall be according to rules and regulations given by MOMRA and MOT specification. MOMRA means Ministry of Municipality and Rural Affairs. MOT means Ministry of Transport. Number 2. Reinstatement of asphalt and surface to existing standards with necessary tests as required by the relevant specifications, unless otherwise stated. Reinstatement shall be to that of the standard width specified for the associated class of roadway, including any bonding. Number 3. Prior to asphalt laying, the edges of the old asphalt shall be recut 15 cm each side to expose a fresh clean surface in class A only. Number 4. Removal and reinstatement of sub-base dimension, width and depth for class A, B and C will be according to the MOMRA and MOT specifications. Number 5. Remove or add material to provide the proper depth of new pavement. Number 6. Be sure the base is properly compacted and leveled. Number 7. Coat the edges of the existing pavement with the bonding agent and then fill the area with hot mix asphalt. Take the asphalt level and compact until level with the adjacent pavement. Here some pictures also illustrates the situation. Bottom right we have asphalt reinstatement and left bottom we have service paving using footpath tile or using tile. Reinstatement of sidewalks. Number 1. In this case of tiled footway, reinstatement shall be not less than the trench dimension specified and shall additionally be to a whole number of width nearest applicable to the standard width for reinstatement. Breakage outside of this dimension shall be the contractor costs and responsibility. Number 2. Paved tiled surfaces and footpath pedestrian shall be restored upon reinstated subbase as it was found before the work, unless directed otherwise by the STC supervisor. Number 4. Reinstatement of concrete surface for special types such as marble, granite and ceramic will be in accordance to the original surface status required specifications. Number 4. Broken tiled or damaged tiled footpath pedestrians shall be replaced whenever necessary. Reinstatement of unpaved roads. The picture down shows the unpaved surface.
or soil. Number 1. In a situation where no paving or hard top asphalt layer exists, it is contractor's responsibility to return any surface excavated to better than or at a minimum standard prior to excavation. Number 2. In a situation where installation take place through plantation areas, non-asphalted hard shoulders or bare earth, the backfill shall be replaced in 30 layer and compacted to meet local standards as per municipality. Number 3. Trees, flowers, bed, lawns, etc. shall be replaced, restored to their original standard as far as it's reasonable. The supervisor's discretion shall be applied.